Uh, okay, so today, what I will give, if you wanted, the a little bit the continuation of what we did the last week. Sorry for the last week, because the in the last week we discussed about the design, and we stopped just when we signed the contract with the client. And today we'll do the next part. So it's mean after the signing of the contract. So we'll do some what I can say, some calculation, and then we will prepare all the document to build the ship. And today I will discuss about the ship itself, about the methods of construction, and also the methods for launching the ship. So it's mean to put the ship on water after the constructions. Okay, this is much more the production unit. So what we will discuss today, it's much more the production unit than really the design and calculations of the ship. So I will give you a small an overview economics context, no, an overview of the economics context, the type of shipyards, the launching system. So it's mean how we can put the ship in water, and the method of construction and the technological evolution, if you want, of the construction. So concerning the shipbuilding industry, it's consuming a lot of manpowers, and some of these manpowers are not skilled, and some it's skilled. It's a half% of this worker or this manpower have a certain skill, and the rest it's just only a worker. So the actually, if you want, is we have a tendency, if you want, to delocalize, if you want, the construction. Why? Because, as I told you, it's consuming, this industry consuming a lot of manpower, and the manpower represent a big part of the construction of the ship. Okay, so it's mean the people are trying to find where the manpower it's less expensive, and you have some skill, the skilled manpower, and then they delocalize the construction there. For example, in Europe now, we delocalized in the beginning of 19, during 19 to the 1990 to Japan, and then from Japan to Korea, and Korea to China. And now China and Korea are the most important industry for the naval, for shipbuilding. In Europe, we continue to do the shipbuilding industry, but just on the what we can say at the greater added value of the ships. So we are not doing in Europe no more bulk carrier, crude oils, or LNG ships. We are doing just only the what I can say, the great added value of the ship. So it's mean passenger ships and naval ships. The majority of the shipyard here in Europe actually doing just two kind of ships, the passengers and naval ships. Why? Because the passenger, it's very complicated to build and ask a lot of high technology, and also for the naval ships, we need a high technology. The biggest industry here in Europe for naval, for shipbuilding, it's in France, Germany, Netherlands, and Italy and Spain. This is the most country where the ship industry it's very powerful. And the eastern country is just more for they have a really an advantage is for inland navigation ships. So if we can see this graphics, so we can see that the number of dead weight, million of dead weight for ship, the demolition ships, and then in blue it's for delivers the ships. And so we can see that in the year 2008 up 2013, we built a lot of ships, and then we also make a lot of demolitions of the ships. And then the curve in blue shows, if you want, the fleet evolutions from 2003 up to 2019. In 2003, we built around we the dead weight for all the ships in millions. It was 800 millions of dead weight, and now we are more or less around 2,000 million of dead weight. So it's mean the shipbuilding industry deliver a lot of ships with the big quantity of dead weight. It's just only less than 20 years, we multiply the capacity by two and a half or three, the capacity of transportations. We can see that the majority of ship built up to now, it's the bulk carriers, the tankers, and a small part the containers and the other ship. The biggest I can say market is for the bulk carriers and the tankers. And so we can see that here the four kind of ships, the bulk carriers, the containers, tankers, and passenger ships. We can see that the bulk carrier, the majority of the bulk carrier are built in China and Japan. And for the containers, the majority of the containers are built in more in Korea, in South Korea, which with China represent around 60 or 70% of the market. And for the tanker, it's the majority of them, it's done in Korea, in South Korea, which represent also with China around 60%. And when we come to the passenger, we can see that for the passengers, we can see that the majorities of the ship it's built in Europe. Are built in Europe. For example, in Fincantieri, Mayer Wharf, and the Chantier de l'Atlantique in Chantier de l'Atlantique. So you can see that the majority of them, the passenger cruise, it's continue to be built in Europe. Sorry, I need to change a little bit the presentation because I am here with the PDF files, and it's not really convenient for me. Mm. is better like this. Uh, Okay, so and then this graphic shows how did China, Korea, and Japan distribute the market between them, and we can see that the majority of the market is for China, Korea, Japan, and just in Europe we have 4%, and in Philippines maybe 1 or 2%, and Indonesia and the other countries represent the rest of the percentage. So why we have for China, Korea, Japan, we have the biggest percentage, if you want, because they build just a bulk carriers, the crude oils, where these ships are have a gross the gross tonnage. It's very larger than, for example, the passengers and the passengers or the other ship, naval ship, and so on and so on. So, but we can see that the majority, the major part of the what I can say the ships and the for transportation bulk carriers and bulk carriers crude oil and so on, the majority are built in China because they have the larger market. They have the cost also. It's less expensive than the other countries. The reason why they have a lot of a lot of markets. This graphic shows a little bit the prices according to the technology, and we can see that in Vietnam, China, we are in low prices, but also the low technology. What I can low technology, it's not the quality, but technology. So it's mean the when you build, for example, the bulk carrier, the crude oils, or the such kind of ships equivalent to those ships, you have no new technology included in this kind of ships. It's just only a, it's equivalent to the same ship built it maybe 10 or 15 years ago or 20 years ago. It's just only what it's new. Maybe the navigation materials is completely new and some small things new, but the forms, the manner to build it, or the probably the capacity a little bit increase it, but it's exactly the same. It's not really completely new technology inside those ships. The reason why we are in low prices and also the low technology. And when we see that in Europe we are in the more medium prices and more or less the high technology, and also in Korea, because now they start to with Japan, they start, if you want to build try to build, if you want, passenger ship LNG ships, which is a little bit more technological than the bulk carriers. So for the shipyard, we have different type of shipyard. According, if you want the shipyard, it can be according to the geographical situation. The shipyard according to the size of the ship that we would like to build, according to the commercial and industrial objectives, and also according to qualification and the labors or main labors that we need. So this is, if you want, the will give you, if you want, the type of shipyard or the position of the shipyard on the world. For example, the type of shipyard. So we can see that we have four type of shipyard, what we call it, or the shipyard established in the coastal area. the shipyard establish it on the estuary or along the river, so inland navigation, and also we have the lakes. This is according to the geographical position. So it's mean the if you are on the coastal area, we can generally build a larger ship, and we need to have, if you want, also the launching system, for example a dry dock, as a system for launching the ship. On estuary, it's equivalent to the coastal, but you are just only in a sheltered area where you are protected, if you want, from the coastal area. And you have the river where you can build just only inland navigation, and in some shipyard you can build what I can say, a smaller ship, but for sea. It's according, or it's the according, if you want, if you are able to transport the ship from the river to the sea. Um, it's the reason why for inland navigation, the majority of the shipyard are building just only inland navigation, and sometimes small ships for the sea. And on the lakes, you have it's equivalent, if you want, to the coastal area shipyard. Why? Because you don't have really restrictions. You are just on the lake. You have generally a larger lake, and then the lake, it can be considered as a sea according to the rule. When you would like to build, if you want, the ships, you need to use the rules, sea rules, and not inland navigation rules, even if the lake is interior water. Why? Because in the lake sometimes you have very large waves, and you need to build the ship according to maritime rules and not inland navigation rules. Okay, the shipyard, you build the shipyard according to the ship that you would like to build. So it's mean you need to have, if you would like to build larger ship, so you need to have a really the devices, if you want, to be able, if you want to build larger ship. For example, the lifting capacity. The lifting capacity, it's really a crucial point for the shipbuilding, and also, if you want, for the economics, it's we need to have a very what I can say, the very good capacity of lifting. Um, why? Because we will see it later. This capacity of lifting will help us to make a blocks, the biggest blocks. And when we build your ship, you build it with different blocks. And if the capacity of lifting of these blocks, it's become bigger, so it's mean you will decrease the number of blocks. And if you decrease number of blocks, you will gain times, and you will have the possibility to do the work faster than if you have the double of blocks. Okay, so we will see what it's mean blocks later in these presentations. Um, so when we say according to the ship, it depends how many ships you need to build all together in the same times. For example, in some shipyards in Korea, they are able, if you wanted to deliver around 30 to 40 ships every year. So it's mean they will have to deliver maybe 2 or 3 ships every month. So you need to have a shipyard able, if you wanted to allow you to build 3 or 4 ships at the same times. Okay, so and then at the end also the launching system is depend, if you want, also on the capacities of the shipyard to build the ships. For example, for ships between 25,000 ton and more, you need to have longitudinal launching and dry docks and floating docks. For the new construction, for repair, you have just only dry and floating docks. And we will see why the longitudinal launching dock is not acceptable for the repair, because it's not a reversible device. So we cannot pick up again from the water the ship. The reason why for repair we have just only dry dock and floating dock. And the next slide, we will discuss, if you want, the different devices. So it's mean the dry dock, the floating dock, the Cyclo Lift, the transversal slipway, and the other devices for construction and ship. And so in this table, you can see that for 2,000, 25,000 up to between 5,000 and 25,000, we can use the same for the new construction, but you can add, if you want, the transversal launching. Okay, for the repair, we stay at the same thing, dry docks and floating docks. Between 50 tons and 5,000 tons, so we use the same. We add just only the Cyclo Lift and a transversal slipway. Okay, and for the repair, we add the Cyclo Lift and transversal repair, transversal slipway. And less than 50 tons, we use the same, and we add the Gantry Crane, and for the new construction, and then for the repair also the Gantry Crane. So we will see all these devices just in few slides. The commercial activities that to make profit to build the ships. For third, we need to have the great quantity of work. Sure, it's normal. Donc to be able, if you wanted to invoice, if you want the cost of the labor, very high cost of labor. This is, if you want, our problem here in Europe in general. Receive more frequent grants. And yes, what it's mean, that it's mean in some countries, they give grants, if you want, to the shipyard, but here in Europe, we are not able to do it because we have the European law, which is very complicated to do it. But some countries do it in different way. For example, in Italy, in France, for example, they give, if you want, the grants to the shipyard by building a naval ship, because Fincantieri do the naval ship for the Italian Navy, and at the same time do commercial ships for passenger ships or something else. So the reason why the Italian Navy said it's all the military ship should be built in Italy. So it's mean they will pay maybe 2 or 3 times the cost of the ship, military ship, for Fincantieri, and then Fincantieri will gain a lot of money with the naval ship, and this is equivalent to the grants the government, Italian government, give grants, if you want, for Falcon Cherry. It's we do exactly the same in France and probably also in Germany. So the and now, if you wanted to do this, is if you want the how to make profits. And now, if you would like to make profit for the by repairing, it's to have the monopoly of the repair shipyards, and also to be on a region where you have a very significant traffic. And for example, Damen bought all the repair shipyard in Belgium, in France, and in UK. And so it's mean the majority of the repair shipyards in the Atlantics, in the North Sea, it's under Damen, if you want, shipyard. So it's mean they have, if you want, a little bit the monopoly, and they will can say the price what they need, because you have no choice if you wanted to go somewhere else. So this is the a part how to gain money. And then you can make a profit by repairing and maintaining, if you want, the ships for a company, for example, as I told you, when you have the monopoly, but also the military arsenals, which is normally what we do for the Belgian Navy, or the French Navy, Netherlands Navy, and so on and so on. So you have also, you gain a lot of money by doing for the military activities. And so what and now about the skill of the staff. The table here shows the different worker you needed to build the ship, and the total staff, the percentage of the total staff of the shipyard. And then in the red colors, it's the skilled uh, workers. So we can see that from 47% of the total of the worker are skilled workers. So it's mean this if we took, for example, in during the effort during the of the war from 1941 up to 1944 in USA, the shipbuilding industry before the war, it was just only 70,000 persons, and during the war, attend 1,700,000 workers. So it's mean a lot of people worked, if you want, in the shipbuilding. And so it's mean during these 4 years, they ask around 800,000 skilled workers to work in the shipbuilding industry. So you can see that at these times, 7% or 14% of the staff, it was a rivet makers. It's just only to to make the ship with the rivet, and so we'll see it later. So how is this? And now this rivet worker, it doesn't exist, and so the majority of them goes to the welders instead to be a rivet makers, because it's no more rivet ships actually. So just to tell you that the skilled workers, it's more or less the half of the total worker in the shipyards. Okay, so it's mean you need a lot of skilled workers to do the work in the shipyard, and 50% of them, it's less skilled. The reason why in the developing countries, you can see that the government would like to increase the shipbuilding industry. Why? Because they know that in the shipbuilding industry you need a lot of manpowers, and around the 50% of these workers are not skilled, don't need to have a specialities. Okay, so the reason why the developing country as Philippines, as Vietnam, India would like to increase because they have a lot of populations, and they would like to increase, if you want, the the increase the shipbuilding industry just only to found a work, if you want, for those people. And now, if this is, if you want, the it was as I told you. So we have 4 points. The first one, the position, the localization or the position, geographical position of the shipyard. The second point, it was about the capacity of building. If you would like to build larger ship, smaller ship, and how many ship you need to build at the same time. The third point, it was the the objective, commercial objective of the shipyard, and the fourth point, it was about the skilled people, or the worker working in the shipyard. And so I explained the different point of view about these 4 points. And now we will go in the layout of the shipyard, how we will build and how we will organize, if you want, the shipyard, and how the shipyard are organized. So we can see that we have, for example, if you have a restricted water frontage, so we have the shipyard, it's a straight line flow, because the frontage, water frontage, it's very small, and so it's mean you have all the flow of materials are in straight line. Okay, we can start here with the stockyard steel stockyard, and then we have the steel processing. What it's mean, this part? This mean is that all the plates and the profiles should be sent in the steel processing. It's just only to sand blast it, and then to paint it against the corrosions. And then from this steel processing, we send it, if you want, to the fabrication and assembly shops. And then from these assembly shops to the burrs, where we can assemble the blocks to have the final ships. And so you can see, for example, you have 3 burrs where you can build 3 ships at the same time. And then you can see around the burrs, you have what we call it the outfitting, and also you have the fitting out case. So it's mean when you finish the hull and you install the machinery, the propulsion system, and so what you can do, you can put your ship on the quay, and you continue to work to finalize the ship completely. So it means you don't need to leave it in the berths all the time. It's just when you finish generally the hull form, you install all the machinery systems, so you are able, if you want to go out with the ship and to put it on the quay and to finalize the ship on the quay. Okay, so you have another kind of shipyards. It's when you have the turning flow, it's a restricted depth. When you have a restricted depth, you can use, if you want, such kind of shipyard layout. You have exactly the same as the previous one. You have the steel stockyard, the steel processing, and then you have the fabrications, and then you can send it to the berth ABC. You have in the second, the other side, you have the machinery, shops, and the outfitting. And if you can see all the time the outfittings, it's near the K, fittings out K. Why? Because you need to deliver all the outfittings if you want it just on the K, and then you can put your ships there and there, and then you have the outfitting directly near the ship to finalize it when you are outside the berth. So this is in Sweden, and so this shipyard are designed for a straight flow materials. And how is the straight? You can see that the stocks, it's somewhere here. You have the shops here. This is the shops to make the elements, panels, and blocks. And then you have the berth, and then you can put the ship outside the berth here. So it's mean this is a strike shipyard. So you can see this, just all everything it's online. Okay. So this is the shipyard in Sweden. And in Japan, the majority of the shipyard, don't ask me why, because it's the majority of the shipyard in Japan are, they have the T layout or U layout. And what it's mean T and U layout? For the T layout, so it's mean you have the outfitting all the time near the K. Okay. So you can have here the steel stockyard somewhere here. You have after that you have the work the shops for assembly shops and fabrications, and then you have the machinery shops, and also you have some part of the outfitting, and you can see all of them. The outside part is perpendicular, if you want, to the berth. Okay, so it means all the flow follow the arrow. You can follow like this, and then they go to the berth. So it's mean it's a T layout, because the final shift it's here, and you have all the other elements delivered to the berth to build the ship are perpendicular to the berth. And the but for the U profiles, and you can see that they have the U. Why? Because the flow, if you follow the arrow, we can see that the flow it's forming a U1. So it's mean you have the flow, and then you can turn, and you have the berth here. It's perpendicular. It's if a U layout. So it's these two layouts. It's according sure to the material flows. And here an example of the two layout, the T layout in Japan, Opama Shipyard and Mitsubishi in Nagasaki Shipyard. And we can see that it's a T profiles. Why? Because you can see here the stocks, the works, the shops here, and then the berths here. So it's mean a T profiles. Okay. You can see this is a stocks, steel stocks, the shops, and then the berths. And here exactly the same. So you have the shops here, and then you have a berth here. It's also a T profiles, a T layout, sorry, a T layout. And then here it's the U layout. So for example, Sanayosa Shipyard, and you can see it's very evident it's the U layout. If you see the building or the shops here and you see the berths, so you can see that forming a U profiles, a U layout. Okay, so you have the shops and then you have the berths here. It's really a U, and this is if you want the outfitting quay where you can see the ships. It's on the quay to do the last outfitting on it. And exactly the same here. You can see this is the K layout, and they have 1, 2, 3, 4 ships at the same time doing the layout for them. Okay, this is if you want the specials in USA. It's this shipyard is completely building the ships for the Navy, U.S. Navy, and you can see how they build the ships. It's a serial of ships because you have one here and the second, the third, and four. You have five ships, and then also you have here also another one. It's six ships at the same time. They doing, if you want, you can see here the panels, the elements, panels, block, and then they assemble the blocks, and then finally they put all the blocks together and to have the completely the ship. So it's a very large shipyard. It's working just for the Navy. And in the after the 1990, the shipyards becomes, if you want, compact, and all workshops are connected with a minimum buffer space. What it's mean with minimum buffer space? It's mean they are doing, if you want, all the what I can say, without any storage part. So okay, so it's mean they built just in time. As I told you, the ship, it will be built by blocks, and then finally with the compact shipyard, they when you finish the blocks directly it's sent to the to assemble in the dry dock. Okay, so it means you are not the possibility to leave it long time outside if you want the dry dock. Also, the reason why you have a compact, the advantage of such kind of shipyard, you everything it's connected all together, and so it's mean the worker doesn't need to go outside to do their work, which is very good things. Why? Especially when you have a bad weather, for example, in the north of Europe, or even in Europe in general, we have a rain, we have a snow, and so such kind of shipyard, compact shipyard, is much more efficient, if you want, when you have bad weather than the open shipyard that we can find in different countries, other countries. So this is some example of the Korean shipyard, and where you can see also, for example, this one Samsung shipyard. It's equivalent also the T profiles. T layout, because you have the workshops and then you have the berths here. It's a T layout. And all these shipyards, it's very large, and they need, if you want, extensive transport are required. They need a very extensive transport. Why? Because you have a very long distance between the shops and also the berths. Okay, but it's I think it's very efficient shipyards, and they are able to build to deliver 3 or 4 ships every month. Okay, now we already seen the shipyards, the layout of the shipyards, and now we would like to see the, as I told you, the launching and and sitting dry, if you want, of the system in the shipyard. I told you that you have what we call it irreversible devices, and what it's reversible devices. Irreversible devices mean, what it's mean, irreversible devices mean that you are not to take out the ship from the water. You can put it in the water, but you cannot take it out from the water. So this is what we call it irreversible devices. Okay, the longitudinal launching, it's irreversible devices, and transversal launching, it's also irreversible. For reversible, you have transversal slipway, dry docks, floating docks, Cyclo Lift, and a gantry crane. And now I will explain each devices, and give you the advantage and disadvantage of each devices. For the irreversible devices, so it's mean the longitudinal launching. So you can see what it's mean. You have a ramp. On the ramp, you have a rails. On the rails, you have a carriage, and you build the ship on the carriage. And when the ship is already finished, you deliver the wrenches, and then the ship enter to the water and goes in the water. So it's very simple and inexpensive construction, because it just, you need to have the ramp and to have a carriage. No problem with water tightness. So it's mean you don't need to have watertight one, because it's the construction, it's over the it's on the land, on the ramp. So it's mean don't need to have something which is watertight. No consumption of energy. Why it's no consumption? Because the just only with the gravity you can launch the ship. No place lost on both sides of the ship, so you can see directly you have the quay, and then directly you can use the quay if you want to do any work on the ship during the constructions. The disadvantage now, it's a non-horizontal key. So it's we can see here in the second drawing, in the second photos, you can see how the ramp is it. It's a inclined ramp, and so you can see that the ship, it's not really horizontal, but also is follow. He follow, if you want, the ramp. So it's mean when you build it, it's not horizontal. So it's a little bit complicated, but it's you can do it. It's complex calculation for launching. Yes, it's very special problems. Why? Because when you launch the ship, the aft part of the ship, it will be in the water, but the fore part of the ship is still on the longitudinal launching system. So it means sometimes you have a disequilibrium of the ship and you can have an accident. So you need to do the calculation and very good calculation to be sure that the ship will be stable when you are between two things. So it's mean the half of the ship may be in the water and the other half it's on the longitudinal launching. So it means it's very complicated and you need to take account during the calculation. Yeah, risk of incident during the launching. This is what I talk about. Um, and this is a reversibility, impossible to dry up the ships. Why? Because it's no way to dry up the ships again when it is in the water. Require a large area and level. So yeah, because when the ship it's moving in the water. So you can see that you have at least, I don't know, maybe 150 meters length of the ship, or two, yeah, 150 meter length. So you need to have at least 3 or 4 times the space in front of this longitudinal system to be sure that the ship, because when the ship is entering the water, he will continue to move, and sometimes he can goes up to 2 or 3 times the length of the ship. So you need to have enough spaces to do it when you launch the ship. And so you can use such kind of system when you are in the estuary part. You cannot do it just in the coastal area, because you have also the wave, and the wave will complicate more the launching and the risk of accident during the launching. Okay, so this is the reason why such kind of devices we use it just only in the estuary and not really in the coastal shipyards. Okay, this is if you want the rails in red colors, and then you can see we build the ship on the rails in the on the carriage, and then we leave if you want the carriage when we finish. This is the ramp in blue, and then this is the water. So the ship it's entering the water, and you can imagine that a part of the ship in the water and the other part is on the longitudinal launching. Okay, on the longitudinal inclining plan. Okay. This is the equivalent to the longitudinal launching. You have what we call it a side launching. So it's instead to have the ship, it's longitudinally put it on the water, we put it just only in transversal way. And so it's you can see the complexity of such kind of launching, because you can see the water around the ship. How is it? So it's equivalent to take the ship and to put it on the water directly. So you can see the water how it's around the ship, and you can see how it is dangerous, or if you want risky to do such kind of launch. Okay, but this kind of launching, the transversal or side launching, it's less used up to now. Okay, it's less used. And now we come to the reversible devices. The reversible devices, what we call it, the sleepway. The sleepway, what it's mean? What is the component of the sleepway? The component of the sleepway is first the ram. The second, it's the winches. Okay, you can have 1, 2, 3, 4 different winches according to the capacity of lifting. This capacity of lifting. Okay, and then you have what we call it the carriage. This is the carriage. And when you see the carriage, it's normally horizontal. Everywhere it's horizontal. So it means this is what it's very important, that the ship stay horizontal. It's not inclined. Okay. So it's mean you can have on the slipway different carriage. You can have maybe 10 carriage. I see a ship yard where you have 10 carriage. So it's mean you have 10 winches. The ten winches are connected all together. So it's mean they are working exactly the same, because you cannot move one carriage. If you have a very long ship, for example 100 meters length, and you use 10 carriage, okay, you are not able, if you wanted to move one carriage at different speed. Okay, you should have all the carriage working at the same speed or at the same movement. The reason why all the winches here are connected together with one shaft. You have one shaft connected all the winches together to make the synchronization, mechanical synchronization, if you want, of the winches. Okay, so you can do it also electrically, but the majority of the shipyard, it's a mechanical synchronization. So it's mean you have one axis and you have different winches, and then and then you have a different carriage. So it means you can, if you have 10 winches, you have 10 carriage. And how it's work, this carriage, it's moving inside the water. This is the water, it's moving inside the water. You have the ship somewhere, and then when the ships, it comes, if you want, to the slipway, to the carriage. And when it is on the carriage, we support, if you want, the ship to avoid any inclination of the ship, and then we move the carriage up, and then we have the ship, it will be outside the water. So as I told you, we can use according to the capacity of the winches. We can use one, two, three, or four, or five, or 10 carriage at the same time. Normally, the capacity of such kind of devices, it will be around probably 2,000 tons. Uh, why 2,000 tons? Because you need a lot of winches if you would like to go up to 200,000 tons. Okay, it's impossible. The reason why we use such kind of devices generally for inland navigation and for the small ships. And here you can see that two ships, and every ships, it's just only on one carriage. Why? Because probably it's maybe it's 50 or 60 tons, and you can carry, if you want, 60 tons just only by winches and one carriage. The reason why you have just only one carriage for each ship. Uh, yeah, so the advantage, if you want, of this slipway, it's a simple and inexpensive construction. Just you have inclining plan, you have the rails, you have the carriage, and then you have the winches. It's no problem of watertight, no etanchity, no water tightness. No place lost on both sides of the ship, because you can directly stop to work on the ship without to lose the places between around the ship. It's reversible, because you can put the ship on the water and you pick it out from the water. No particular water level necessary. It depends if the ship are able to attend the shipyard or not. So the disadvantage, it's the energy consumption, because you need winches, maintenance underwater trucks. Don't forget that this rail continue under the water, okay, because you see the water arrive to here, and this rail continue under the water. As I showed you in the previous photos, you can see the rail continue up to here, and then sometimes you need to make a maintenance of this rail because you are under the water and it's very complicated to do it and it's costly to do it. So you need to maintain, especially when you have a sand coming, if you want on the rails. Okay, at this time you need to clean the rails very often. Limitation due to loads and to be raised. As I told you, generally it's not really done for larger ships. This is another photos about the slipway. You have also what we call it this longitudinal slipway. Why? Because you have just only we can say one carriage with very large winch, and then the ship is entering here, and then when you are here in the middle, you are on the platform where this platform can be turned, and then you can storage if you want on this garage area. You can storage if you want the ships. So you can put it one here, another one here, another one here, and then you can be sure that your slipway it will be free all the time, because when you do the reparations and maintenance, it's sometimes it's very complicated to it's very complicated, and you need to use your slipway very often. So you can, if you want, you can use it by using such kind of system. It's also very old shipyard, but it's exists, but it's very old shipyard, and I never seen a new shipyard with this kind of devices. The dry dock, it's equivalent to the, we can say to the locks. It's equivalent to the lock. So you have just only one door instead to have two doors, and then when the ship is entered this dry dock, you close you close the door, and then you empty the dry dock from the water, and you will have completely the ship outside the water and without the water, and then you can work around. And when you are building new ship, it's equivalent to what you do. You fill, if you want, the dry dock with the water, and you open the doors, and the ship is go out directly. Um, so the dry dock, the advantage is reversibility. It's reversible, no limit of load, because for the dry docks you can have a ship with 400 meters, which more than I don't know, maybe 100,000 tons. It's no problem for that, because it's completely on the in the construction. It depends on the construction and the possibility to of the weight, and so it's no problem for these limits of load. Can take several boats at the same time. Yes, because if you have a very long dry dock, so it means maybe 400 meters or 300 meters or 400 meters, you can close a part of these dry docks. You can start to build one ship, and then you build from in the second part another ship. So the problem is just only a logistic problem. So you need to finish the first ship, to take it out, and then to be able, if you want to take out the second ship. Okay, so it's mean you need to make a logistic things. After that, you have the horizontal key. Sure. Disadvantage, it's a complex and expensive construction. Yeah, because don't forget you are near the coast, near the water, so you need to have a very strong construction. And you have also the gate, because you have the gate for the dry docks. So it's a problem of water tightness and consumption of energy also, because you need to have the pump for draining, and you need to have a crane with a great range, so it means big capacity. And we will see some shipyards, for example, in Chantier de l'Atlantique, where the crane it's more or less 1,000 tons capacity over, if you want, the dry dock. Handle only one vessel at a time. So it's mean if you are on the dry dock building the ship, you cannot you block, if you want, completely the dry dock. You cannot open it and then you take another ship, you close it. No, you need to finish completely the ship, and then you can fill it with the water and open the door. So it's mean if you are doing the new construction, you will block your dry dock maybe for 1 year or maybe more than 1 year without to open the door, because you are not able to open the door because you have your ship in construction. So the reason why you can handle just only one ship at a time. You cannot use it during the construction of the ship. Okay, this is if you want the dry dock in Chantier de l'Atlantique. So you can see the dry dock. It's a very large dry dock, and then you can see the crane over the dry dock, which is a very powerful, if you want, the crane, which the capacity of lifting it's 1,000 tons. And we can see, if you want, the dimension, because here you have more or less, you have more. I'm sure that you have at least 2 times the width of the ship as a uh, width of the crane. So you have one times here and you have a second times here. So here, if you want how it's works, so it's the ship, it's you put the ship here, and this is the blocks, and you can move the blocks to the ship, and you will finalize the ship outside, if you want, the dry docks. Oh, this is if you want the separation between, when you have very large dry docks, you can build two ships at the same time, and this is if you want the separation of between the in the dry dock. Oh, the floating dock, it's a little bit different because it's a pontoon it's a pontoon for drying the ship, and processing, if you want, a floatable buoyancy, and the chambers, chambers, and you have the form of the section with U sections. And so it means when you would like to use it, so you fill this pontoon with the water, and then the pontoon will sink, and then the ship enter, if you want, between the two U element, and then you uh, the deballast, if you want, the water. You take the water out, and the ship is move up and take the ship at the same time. And so this is, if you want, the dry docks. What is the problem of the advantage is irreversible, because if you would like to put the ship again on the water, you fill the ballast with the water, and then the ship will sink, and then the ship can go out, and exactly the same. You another ship it's enter, you empty the ballast, and the ship is moving up, and move the ship with the at the same time as the driver. Okay, the mobility is very easy because today you have it in one point, and then if after two years you would like to move, so you can move it maybe 20 or 30 or 100 kilometers far from the first point. It's no problem. You do it by the tugboats, and then you can put it where you want. This is the, if you want the advantage of the dry dock, it's immovable dry docks. It's much more easy and to move it and to change the localization and the positioning. Disadvantage is complex and expensive. It's a ship. You build another ship, expensive to maintain. Yes, it's equivalent to the maintenance of the ship. So every 5 years, you need to take it out to clean it, to paint it, and so on. Difficult to handle for construction of ship. Why? Because if you would like, you can do it. It's nobody tell you not. You can do it. You can build the new ship inside, but you should be sure that during 1 year you will not use the dry dock. The dry dock it will be just only for this construction, and will be stay during 1 year without moving. So the reason the dry docks are often used for reparations. Complex calculation for operations, yeah, because you need to ballast and so on, to do the ballast exactly at the good level and so on. So it's a little bit complicated, and but it's feasible. Need for having a sufficient mooring, because you need to moor it, because it's impossible to leave it like this. If you have a current, so it means the dry dock will move with the current. How it is the dry dock? This is a dry dock, so you can see this is the pontoon here, and on the side of the pontoon you have the four, we can superstructure, if we can say that, and then you have a lot of ballast tanks inside this pontoon. So when you fill it with the water, this pontoon is go down up to the maximum, this line, the blue line, okay? Up to this blue line, it's entered to the water. So it's mean this height, it's equivalent to the draft of the ship. This is the how you can limit if you want. It's the draft, but also the weight of the ship. Okay, so it's mean this pontoon, you need to stop it here, because this area, or this the volume will help you if you want to have a very stable platform or stable floating dock. This is another floating dock. Uh, this is a floating dock, which is for me it's the better one, because you have a lot of crane, so it's mean you can work without to need to have a crane on quay, okay, because he has his own crane, and he's another one where you don't have a crane on board, and he used the crane, if you want, on the quay to deliver the material for reparation. Okay? And then the Cyclo Lift. The Cyclo Lift, it's a lift for ships. It's you have a platforms. This platform is attached to what you see here. These boxes is the winches. So you have the winch, the cable, and then this platform is attached to the cable. And when you need to have the ship outside the water. This platform will move down. Okay, the ship enter. When the ship enter, if you want this on the platform, so you can lift the complete platform with the ship, and then you have the ship in a dry position, and then you can move after that because the ship is on the carriage. And if you would like to move the ship outside the Cyclo Lift, you can move it outside. You make the reparation maybe during 2, 3, 4, 5, 1 month of work, and then you bring it again to the lift and you put it in the water. This is the idea. If you wanted to be able to move it out the Cyclo Lift, it's just only to have the Cyclo Lift completely all the time free to use it for other ships, other ships. So this is the Cyclo Lift. So you see, you have the rails here. The ship is on the carriage, so you can move if you want to be the ship on the earth here. You work on it, and then you bring it again if you want to the Cyclo Lift to put it on the water. Also, you can see here you have different elements, and this is if you want the Cyclo Lift here. This ship is in the Cyclo Lift, and this one it's outside the Cyclo Lift, because after that you can also move it transversally by changing, if you want, the direction of the wheels. Okay, the advantage: horizontal keel, less expensive than the dry dock and the floating dock. No problem with water tightness because it's you have nothing if just you have the carriage which is in the salt water, but the rest of the mechanism it's outside the winches, it's outside and so on. So it means no problem of water tightness. Disadvantage: require very resistant foundation, yeah, because it depends on the capacity of lifting. A bad accessibility for the crane. Yeah, you can see here, it's no way to put some crane because all this construction it's in the water, so it's impossible to. Yes, it's possible to do it, but it's costly, and it's no way to have a crane on this area. So it's impossible to have it because it's on the water. Require maintenance of the winches. The maximum capacity is 30,000 tons. This is the maximum capacity of lifting. The gantry crane, it's equivalent to, this is a gantry crane, so it means just a structure. You have the wheels, and then this crane, it can move over the water because you have two way for moving. It's a U profiles, if you want. Here on each side you have the possibility to use the wheels on the quay, and then the ship enter if you want, and then you take it out, you lift it, and then you move with the ship, and you put the ship on the ground. Okay, so it's mean the require on the track. The tracks are pneumatic ones, generally pneumatic. It's not really on the rails. A pneumatic, it's much more flexible. You can move it, and you can move with the crane everywhere. Operational safety. Yes, it's more or less it's safe. You can put your ship on the ground where you want. It's not really specified where it should be. Disadvantage is limited of for the small units. You cannot lift very large unit. It's maybe 15, 20, 15 to 20 tons, the maximum. Maintenance of various machines parts because it's at the car, so you need to maintain mechanically if you want the system. Okay, this is just a overview of what we discussed about the reversible devices. You have the Cyclo Lift, you have the dry dock, you have floating dock, and you have the slipway, longitudinal slipway. Yeah, in that case, it's a longitudinal one. So this is the main reversible. Yes, sure, you have the Gantry Crane, but it's not represented here. But this is if you want the all the reversible devices. Okay, now I will move to another presentations where we talk about the where is it? Oh, just a minute. Okay, remove this one. Yeah, this one. Okay. Now, if you want, I would like to discuss about the method of construction. Uh, so you see the ship. It's built like this. So you have the hull structure, and when you have the hull structure, you need to make the tracing of plate. So it's been cutting, punching, bending, and forming. You'll do the pre-assembly elements and the block prefabrication, installation of large equipment, and assembly of the hull. And you have the outfitting, our outfitting equivalent to the propulsion machinery, a line of shaft and propeller, piping, ventilation, electricity, woodworks, and plumbing and furniture. This is if you want the outfitting, and this is the hull structure. Generally, I can say generally, when you finish the hull structure and the propulsions and line shaft and propellers, you can put the ship outside the dry docks, and you do the all other outfittings directly with the outside the dry dock. So it's been on cave. Okay. So now we will talk a little bit about the hull constructions, and I would like to give a short, just only 2 slides about the hull constructions. Before the Second War, all the ship was done by rifting and longitudinal launching, and many labors work if you want in the shipbuilding. End of the Second War, after the effort of war in USA, the welded panels constructions begin. Optical trussing by projection also begin, which is now completely disappeared, and with other things. After the 1970, the construction power blocks arrive, and the use of your computers, the allow, if you wanted to you don't use the optical tracing by projection. Okay, now everything is done by computers and by automations and optimizations. So it's mean it's if you want this is if you want the evolution of the shipbuilding. We start with the rifting, longitudinal launching. Now, after the Second War, we start the welding, which is continue to be the hull. It's continue to be welded, but the optical tracing now it's are replaced by the computers and the nesting, and we will see what it's mean. And after the 17, if you want, the computers takes more and more places in the shipbuilding industry, and also the automations. So it's mean the robot. Now the majority, the large shipyards, for example, Cantieri, Meyer Wharf, all the Korean shipyards, all the Japanese shipyard, all the Chinese shipyard that have, if you want, the robot in the shipyard. And so it's very impressive about the robot. And the first people who start to make the shipyard robotization in the shipyard, it was the Japanese in 1980, around the 1980. Okay, so this is the evolution, if you want, of the techniques to build the hull. This is the just to give you, some of you maybe knows about the rifting. What it's mean, the rifting. The rifting what's mean that you have two plates. You make a hole between the two plates, and then you put some, if you want, the rivet, you put the rivet, and then by using by using a hammer, you can close the rifting, close the rivet. Okay, so it's mean you have additional weights, which is 30% more. And where you have 30% more, because this coming from the double of the plates here. Okay, sometimes you have more than one rivet. Sometimes you have maybe 3 or 4 rivets. So it's mean the covering of the plate, it's much more wider, and so you double every time the weight of this surface. Difficult to water tightness, yes, because it's just only the rivet. And how it's worked, the rivet, because the rivet, before to put it in the hole here, it's you need to heat it up to, I don't know, maybe 800 degrees or something like that. You put it in the hole. You use the hammer if you want to make the rivet equivalent to this form, so around the round part. And when the rivet it becomes cold, so it's mean you will have, if you want, a retractions, and then he compress, if you want, the two plates together. Okay. Um, Waste of time and labor, yes, because if you can see the ship with rivet, you can see that the rivet, you have a rivet every maybe a few centimeters, every 2, 3, 4 centimeters, you have one rivet. So you can imagine how much time you need to make a hole and then to put the rivet. Instead to compare, if you want 1 meters of rivet, to compare it to the welding, you will gain a lot of time because you need to make the hole on the 2 plates, and then you need to put the rivet, and you maybe 1 or 2 or 3 row of rivet. And then with the welding, it's just only one weld for it, and so it's much more quicker. And roughness of the hull. So don't forget that the roughness of the hull is very important. Why? Because you will have, if you want to be, the frictional resistance will increase a lot. Why? Because all the time you have a step between two plates. You have a step between 2 plates because you have the thickness, and you have also the rivet, also which give you also a larger roughness, if you want, of the hull. If we compare it to welding, we'll profit weight of 30%. It's normal. Um, Guaranteed of water tightness. If you do the welding very well, it's you will have a very watertight hull. Continuous assembly. Yes, you don't have, if you want a what I can say, you don't. It's really, you don't have a step between two plates. It's just only a continuous one. It's a continuous plate. Uh, so it's yes, because according to the rifting, it's very complicated to disassemble. With the rifting, it's very easy to disassemble. Less materials, and also less expensive because you don't have the double of the plate. Now the welding, it's a problematic. Why? Because you have the possibility of cracking. It's not possible for the rifting. For rifting, you have less cracking. Why? Because even if you have a crack, so you will have it and then continue. And when you arrive to the second plate, you will stop the crack because it's impossible to continue. It's just only one. But here, if you have a crack with the welding, so it's mean the crack can continue on a larger, if you want, distance than if you have a rifting. So the rifting is not used anymore. If you would like to see some rifted ships, the majority of the rifted ship, it's actually in inland navigation. You have a lot of ships for inland navigation, and especially the smallest one, which is the 38 meters or something like that, which is continue to use it as not for the transportation, but it's more for habitations and so on. And this hull of those ships are all of them are rifted. Okay, so now I would like to tell you how is it the range of speciality, if you want, for each ship, especially for the passenger ship. So for a metal hull, design, manufacture, and assembly, it's 50% of the main power. So for the passenger ship, energy and fluid, it's just 24%, and electricity 9%, painting it's 3%, and accommodation it's 14%. So you can see that the hull, it's taking 50% of the main power of the complete ship. Uh, to make the steel works, so it's mean for the hull, you have 80%, it's considered for the labors, the cost of labors, and 20% for the materials. And so it's mean if actually the materials for 1 kilos, you have more or less between 1.1 euro the kilo, or if you have the cutted plates, maybe you need to add maybe 20 or 30 cents for 1 kilo. So it's mean the cost of 1 kilo of steel cut it, it's equivalent to 1.3, 1.4 euros the kilo. And then if you need to have the cost, so you need to add 80% of the cost of the steel. So this is just only to give you an idea. For example, for the bulk carrier, it's 70% of the cost of the bulk carrier. It's for the steel, and 30% for the rest. So it means accommodation and machinery. So you can see, but for the passenger ship, it's more. For the hull, it will be probably 50% or a little bit the cost, a little bit less, and the rest is for the other things on board the ship. So it means it's completely different. The reason why we continue to do this kind of ship, because the technology of the passenger ship, it's much more complicated than the technology for the bulk carriers. Okay, and you can see when you have 70%, it's for the steel work, and this is very good if you want for the country where the main labor it's very low cost. They have very low cost for the main labor. For example, in China, Vietnam, and so on, they have very, very low. If we compare the salary of a welder in China, which is maybe equivalent to 1 hour of work here in Belgium or in Europe in general. In Belgium, in Europe, it's for the welder, it's between 35 and 40 euros for 1 hour, and probably you will pay maybe $20 or $25 a day in China or in India. I don't think so. They have arrived to 20. It's probably less than $20 a day. So it's mean for 1 day work in those country, developing country, concerning the for according to what we do in Belgium or in Europe, it's for 1 hour of work. So you can see the difference when you have a lot of steel work to do. So you gain a lot of money. Now the flow chart, if you want, for shipbuilding yard. So it's mean, as we can see, and as I show you in the previous presentation, where you have the layout of the shipyard. So you can see the first one, it's the store plate and stiffeners, where you have the sandblasting and so on. It's included in the post in the flow number one. The workshop machinery and bending machine to bend, and the element it's on the is second step. The buffer storage is just only to store what you did before to start the construction of element, panel, and blocks. It's a buffer storage. The number 4 and 5 and 6, it's the pre-assembly for the element, and workshop pre-assembly for panels and the blocks. And the 6, it's launching and to the dry dock. So it's mean you send the blocks to the dry docks. And 7, the completion afloat, if you want, for the outfitting. Now, if you would like to do a very large ship for the construction of ship, very big ships, you split it on number 4. So if you, after the buffer, when you are doing the element, you split it to 2 lines just to be able to go faster, to build the panel blocks, and to send it, if you want, to the dry docks and then to the outfitting scale. For the ship repair, it's we miss, if you want, number 4, 5, because you don't need to do the panels and the blocks, because just you doing a reparation. The reparation, it's enough just to do maybe sometimes some bending element and to prepare some elements and then to send it to the dry dock to fix it on the dry docks by welding this element. And then you have 8, 9, 10, and 11, which is much more for workshop electrician, piping, and workshop carpentry and mechanical work, which is it's not really as the for the new constructions. Okay. Okay, this is if you want the general layout in general for the shipyard. So we will see exactly the same element as I explained for the layout, but also according to the flow chart of the shipyard. So you will see exactly the same, but here just only with photos and the area on the photos, just only to show you the different area and how the ship in general are is it. Now this is very important, as I told you, for this what we call the pre manufacturing, where you will have, if you want, all the element here. So it's mean you have here the plates, you have the profiles, and then you assemble to have an element. An element, what it is mean? It's mean that you have a plate plus the profiles, and then we call this one a pre-manufacturing. When you have the so panels, so it's mean you will have the element, you assemble element between them, you will have the panel. And when you assemble the panel between them, you have the block. When you assemble the block between them, you will have the ship. This is, if you want, how actually the the construction of ship. So it's mean you have plates and stiffeners. You can do element. From the element you do the panel. From the panel the block, and the block you have the ship. This is, if you want, the step of the construction of the ship. And now I will show you in drawings what it's mean. So the element, it's just do not exceed a few tons. So it's mean you have a plate plus profiles. The panels, so these panels, this element, if you want, you have it. You have one element here, a second element here, and the third element here. So you have, to do this panel, you have three elements. The element, it's just only plate plus profiles. You have for the bottom, you have element for the double bottom and for the side. Or this is a panel, okay? And then if you, and generally the panel, it's between 75 to 100 ton maximum. Now, if it comes to the blocks, what it is the assembling the panels. This is one panel. This is, if you want, we can, if the panel it's equivalent to the element, so it's equivalent to the element, because here we don't have a double bottom, but we have just only the deck with the profiles, and we have the side here, and we have maybe the pillar, and this is, if you want, the block. We call it the block. So we assemble the panel to have a block. So don't forget that you have the element, you have the panel, and you have the blocks. All these things, why we do it like this? Is it just only to avoid the work, the outdoor work. Why? Because if you have just only the element, and if you will move all these elements outside, for example, to assemble all these elements together, you will lose the time and you will work outside. So if you have the rain, it's very complicated for the welder. If you have the snow and it's very cold, so you imagine to work 8 hours when you have the temperature -10 or -20 in the outside. So it's impossible to weld, okay? Because the welder, you cannot weld the steel if you have more than, you should be at least 2-3 degrees. Why? You can do it, but you need to heat before to start to work. Also, do you imagine the work? So the reason why now the majority of the shipyard are working inside before they instead to do it outside. So it's even major work. But now they have a very large, what I can say, the building where the ship is built inside the building and not outside. It's a compact shipyard. Okay. Um Now, the when you build the ship with the blocks, so you have the blocks, you need to adjust the blocks between them. Okay, so it's very complicated. After that, this is if you want the block splitting for the bulk carrier. You see the number of blocks to build the ship. And now this is if you want I will show you some photos how to the flow chart if you want of the shipyard. So this is the steel stocks. You have here a shot penning and the painting. This is if you want from the 3D model of the ship. As I told you, instead to have the optical projection, now it's sent directly to the computer. The computer put all the elements of the ship on a plate. You can just decide which plate you need to use. If you say, I need to use the plate 6 meter length by 2 meter width, just if you want the computer will send all these elements, we place all these elements if you want, and we send the file to the cutting machine, and the cutting machine will cut all the elements by putting, if you want, all the number on the pieces, and then the company, the design office will send to the worker the bulkhead here, for example, with all the name of the element, each element, and the way to do it. So it's mean they told to the worker, you need to start with this one, after you need this one, this one, this one, and they show them if you want how to build it. It's equivalent to what you receive, the drawing you receive it when you buy something in IKEA store. It's equivalent to that. So you will have the drawings with all the steps to do how to do it, and with all the pieces, and exactly the same. We do exactly the same. Oh, this is the cutting machine. So it's mean it's the plasma cutting machine. Okay, so it's mean the plate it's under the water to avoid, if you want, the gases and the noises. We use this water. The plate it's inside. We see, if you want, on the drawing, we see here some plates, cutted the plate. And this is, if you want, what the computer sent to the machine and what the machine cut. This is for the bending of element profiles. For example, this is just only the profiles, to bend the profiles here. And this is if you want to weld and to the T shapes, because you have the flange and the web and the flange, and this machine just do such kind of profiles. This is the bending of the plate. This is the mechanical bender with 3,000 tons, just only to bend if you want the plate before to put the stiffeners. Or this is the pre manufacturing. So it's mean just you have the plates and the profiles, and just maybe the welder are just fixed the profiles on the plate, and then the robot will continue the work. This is if you want the panel lines. Just as I told you, it's impossible to do the ship with just only one plate. So you need we need to have the different plates all together, and then we will build the plate all between them. So it's mean here you have 1, 2, 3, 4 plates welded together, and then we send this plate, if you want, to another machine where we put the stiffeners on it. So as I told you, the panel lines, we produce, if you want, the plates. On the plate, we put the profiles. And from this element, we just prepare to do the panel. And we do after that, the blocks. Okay, why we do that? We do that because we need to avoid the works on the we have to facilitate, if you want, the welding. Okay, if we see the plate thickness according to the cost by hour, we can see that the weld overheat, it's much more expensive if you are on the flat welding. So it's mean when you have it's much more easier if you want. It's equivalent to when you are painting it at your home. If you paint the floor, it's much more easier to paint the floor than to paint the wall. eh, The or to paint if you want the over your head. Okay. So it's much more easier. So the reason why we try for the welding to do exactly the same. The reason why we do the element where the element you do it on the ground, you weld everything on flat on the ground, and then you assemble to do the panel, but you do it also on the ground. And when the blocks also you try to do it on the ground. So it's mean I will show you how we do it. For example, if you would like to make the deck with the bulkheads, you do it on the ground, and then you turn it, you weld it up and down. So it's mean so you weld everything on the flat, and then you turn. Okay, don't forget the cost of this element. Flat is much more cheaper than horizontal, than vertical, and then overhead. Okay, don't worry about the also the weld for the butt weld if you want for the plates. Okay, this is if you want what we do. This is the deck. It's on the flat. We put the bulkheads, and when we finish it, we can try to turn it, and I will show you the machine. Now, this is if you want the machine of the chamfer, because if you want to make a welded on X, you need to have a chamfer like this one. You weld on the first face, on the first weld, you weld this one, you turn all the plate, and you weld the second one after. And so I will show you how we do it. This is just only to deliver the plates to the line panels. Here you will see the guy with the robot is preparing to weld this plate on one side with the robot. This is the first welding on one side done by the robot. and then this is different plate, 1, 2, 3 plate, and then this machine turn all the plate to weld the second side of the plate when you have the X chamfer. Okay, so this is the machine. This we are here. You turn if you want this plate. Okay, this is now you have the plate welded on both sides. You have different lengths of the. You have 3 or 4 plates welded all together. Now here what you see this line, it's preparing if you want to put the stiffeners. So it's mean just the machine take out the paint, and then another machine comes to put the stiffeners, and the robot will weld the stiffeners on both sides. This is just only the stiffener positions. And then you can see here the robot, it's welding, if you want, on both sides, the stiffeners on the plate. Oh, this is the robot. And this is, if you want, this is just only to show you how the one of the robot is just putting some point, and then the another robot will do completely the welding along these stiffeners. This is how to fix if you want the frames on the deck. This is if you want a deck. It's not if you want the bottom. It's the deck, and then you see here you have the bulkheads. Okay, now we are doing the deck here. And then it's just only this is the panel line, so the plate plus the profiles. And this is if you want the sub assembly. You have the deck, you have the bulkheads here, everything it's done. And yeah, this is another view of the robot working. And you can see here the robot, 12 robot, it's working just only on the double bottom. You see the double bottom here, and this is the robot. You have 12 robot working on the double bottom. Or this is if you want to be the wind, the post of welding. If you want all the electricity coming from the top and not on the ground. Or this is the complete, we can say, the big panels. Why? Because this is the deck, this is the bulkheads, this is the cofferdam, and we assembled some element. If you want, you can see this is, for example, the pre-outfitting. Probably it's maybe it's the exhaust gas. And this is machine if you want to turn up and down, to turn if you want the device to turn. This is the bolted on the floor, and then when you finish everything, you turn it and you put it directly on the second on another deck. And so you can see the all the work here, it's already done on flat on the ground, so it's mean flat welding. So now what he will do when you put it again on the to make a big block, a blocks, you need just on to weld it this to the structure of the deck. So it's mean it's much more easier, and you gain a lot of time because all your work is done on the ground. This is if you want the block with the outfitting. So on the tracks, this is moving if you want to the dry dock. Or this is a prefabricated bulb. It's one block. This is considered as a block. And this is if you want the number of block you have. and this is the ship during assembly. This is what we call it assembly zone. So it's meaning this crane, the big crane, will take this part and will put it on board the ship. Or this is if you want some blocks, and then here also you can see the blocks. Here you have different blocks showing different blocks, and this is the manner if you want to work. So it's mean you have the blocks and you start to assemble the blocks, and you have a manner to assemble. You cannot do it as you want. It's done if you want by step by step. Okay, so you can see okay, what we see here. You see this is one, it's equivalent to one block, which is the bulbous ball. And now you can see this is the complete shape according to the number of block that you have. You build it in the workshop, and then you bring it if you want on the dry dock to do it. This is in my work, so you can see how this is a section of this building where you have the ship inside the dry dock. You have a lot of cranes. You can see here 800 tons. Here it's 4 by 60 tons, and here you have 6 by 16 tons. And then when you finish completely the ship, they open the door, the water comes inside the dry docks, and the ship can leave if you want to be the dry dock. So a lot of problem of distortion. This is the main activity of research in shipbuilding. It's to see how to decrease, if you want, distortion of this plate. Because it's very complicated when you assemble two blocks. It's very complicated you need to work on this part before to assemble the block. So the shipyard are interested, if you wanted to see how they can decrease, if you want, distortions. And another problem, if you want, it's the block erection. So you have a gap, and you need, before to weld it, to decrease the gaps at minimum as possible, because if you have 1 centimeter or 2 centimeter of gaps, it's impossible to weld it. So you can use the jack if you wanted to compress these two elements together, and to be able, if you want, to weld it. As you see here, we use this jack just only to be able, if you want, to connect two blocks together. Voilà, okay. So we finish for today. I hope that I hope that you follow completely the course today. Concerning the exam, it will be I will give you different questions, two questions. I think two questions for this course and two questions for the design. And uh, and it's not really an open question, but it's a question with you can multiple choice, and you can use this multiple choice if you want to answer to your questions. So in total for the two courses, it will be yeah, I have a question here. The reason, what is the reason? What was the main reason the panel are assembled upside down? It's the reason I explained it several times. But anyway, it's to have to weld all the element on the ground. So to have on flat welding instead to have overhead welding or vertical welding or longitudinal welding. Okay, this is the main reason, if you want, to do the panel assembly up and down, just to do all the works on the flat position instead to do it on vertical or overheat. The reason why you have the element, it's the plate plus plus the profiles. When you finish, if you would like to do the double bottom, you will have one plate with the profile, second plate with the profile. You turn it and you weld it all together. Just if you wanted to avoid the weld overheat or the vertical or horizontal, just only that. Um, you need to learn a presentation document on document 1B. I don't 1B what it's mean 1B. This is 1B. I think this is what I present now. It's 1B. Yes. The no, it's 1B. I will ask as I told you, the question it will be a multiple choice, and so please you read it and then you can see it's not really. I will not give you an open question and you need to make several pages. It's just only multiple choices. I am reading if you want. Sorry, I'm reading just only the question. Last week we only heard you about half an hour. Suddenly next to me, but I think you lost the connect. Okay, yes, as I told you, so I am waiting. If you want, if you would like, I can give you another. If you have a time, I can give you. If you want the explanation again, it's no problem for me. Please, you can send me the mail. Your one of your colleague have my phone number, so you can give me call or you can send me the message and I will organize with you another session. Okay? Do you have other questions?